Hey, we're at example 5.4.7, where we're asked to graph the curve r is equal to 2 sine theta, so that's the form r is a function f of theta, by making a table of values. So we're given a nice polar graph paper here. So let's make a table of values to get a handle on what that curve looks like. So our theta is our independent variable, our r, which is 2 sine theta, is our dependent variable. So our table of values will look like this. So we'll start with theta as 0. So theta as 0 is along the positive x-axis. So r is 2 sine of 0, which is 2 times 0, which is 0. So angle of 0, radius of 0, we're getting that point right there. So let's go and move up through the traditional trig circle values. So pi over 6. So r is equal to 2 times the sine of pi over 6, which is 2 times 1/2, which is 1. So at pi over 6, we have a radius of 1, and so we're looking at that point there. Right, so we're imagining that the curve, if it grows continuously, is growing sort of like this to reach that point. Now, next value, which is not on our graph here, but is right smack dab in the middle, so pi over 4. R is 2 sine of pi over 4. That's 2 times root 2 over 2. So that is root 2, which is approximately 1.4. So at the midway point here, we're a little bit past. We're not quite at 1.5, so somewhere there. And then we'll just keep on going at pi over 3. What do we have? R is 2 times the sine of pi over 3. That's 2 times root 3 over 2, which is root 3, which is about 1.7. So at pi over 3, we're at about 1.7-ish, so maybe about there. And then at pi over 2, what do we have? We have r is 2 times the sine of pi over 2, which is 2 times 1, which is 2. Where's my 2 line? Here. So if we imagine these being joined nice and smooth, we're getting what looks like a semicircle. And if you continue to plot points, you know, the sine function is symmetric around pi over 2. What do I mean by that, right? The graph of the sine function. We have just graphed the values from 0 to pi over 2 on that part of the function. The next part of the function from pi over 2 down to pi matches exactly, right? So all the points that we've plotted, we're going to get the same radius for those theta values. And so we know we're going to get here, where's my pi over 4? Here and here. So we're going to get the other half of this circle. My drawing skills leave something to be desired, but this looks like a circle up the positive y-axis. Now let's take a quick look at where the center of that circle is. The center is here, which is not at this 2, but halfway. So that is a center at, in rectangular coordinates, 1, 0. And we're going to see in our summary of this that this is a form r is equal to 2a sine theta. Here RA is 1, which is going to be a circle centered at, I should write circle as well, shouldn't I? A circle centered at the point A and 0 on the y-axis, And with radius, well, what's our radius? Our radius is also, right, this goes up to 2a and from 0, so our radius is a with radius a. So that is one example of a polar curve of a circle centered on the y-axis. In the next video, we'll look at example 5.4.8, where we'll graph a curve which is even more intricate.